The article I chose was by R.J. Herstein and Philip Heinlein, called Negative Reinforcement as Shock Frequency Reduction. But before we jump into the article, let's do a review. What is negative reinforcement? Negative reinforcement is the termination of a stimulus immediately following responding that results in an increased likelihood that the response occurs in the future. When studying negative reinforcement, Sidman in 1953 discovered the avoidance conditioning procedure, which was brief, intense, and inescapable electric shocks presented at regular time intervals to rats in a chamber with a lever. Each time a rat pressed the lever quickly, shock was postponed. Rats were only unpunished, or not shocked, when they were pressing the lever. A few years later, Sidman expanded on their own study by using the reduction of shock rate as reinforcement, not just the termination of shock. And around the same time, Inger used the same procedure but used different conditioned aversive stimuli. The purpose of the present study was to see if the rate of shock is a controlling factor in avoidance. They wanted to see if the level of shock affected the rate in which a rat would press a lever. The study used 18 rats, 14 female and 4 male, who were 200 days old. Who remembers the benefits to using rats as opposed to other non-human animals in experiments? The rats were put in a standard rat box, which was a stainless steel box with grid bars, a lever, transparent ceiling, and sloped sides to prevent climbing. The shock was applied to the walls, lever, and grid bars and occurred for a duration of 0.3 seconds. The experimental design in this study was a multi-element design with the independent variable as shock probabilities, or variations in shock intensity, and the dependent variable was the rat's rate of responding. This study had a few different conditions, but overall, shocks were programmed to take place at 2-second intervals. A higher shock was delivered if a rat did not press a lever, but if the rat did press the lever, a lower shock rate was provided. Different conditions in the study also had different ranges of shock magnitude. Based on what you know about the study already, do you think that the rat's rate of responding will increase, decrease, or remain constant? As previously mentioned, there were many different conditions which resulted in many different graphs. However, I found these graphs to be the most interesting. First, let's take a look at Figure 7 on the left. The x-axis shows seconds, the y-axis shows the mean responses per session, and M1, 2, and 3 were the rats. What's interesting is that each rat had an immediate increase in responses per session after the first second, and then immediately decreased. Then, responses tapered and remained around a constant level of about 80 responses per session for rat 1, 90 responses per session for rat 3, and about 110 responses per session for rat 2. To review before we discuss the next figure, what does conditional probability mean? Conditional probability means the likelihood that a target behavior will occur in a given circumstance. In Figure 8 on the right, the x-axis is the probability of shock, or average shock per minute. The y-axis shows the responses per minute. The open circles represent the rate of shock being held at a constant 0.3 level, and the closed circles represent the varying shock trials, meaning the shock varied in strength, ranging from 0.1 to 0.5. As you can see, the responses per minute decreased when the rate of shock was held at a constant 0.3, but increased when the shock level increased. This graph shows conditional probability because the responses per minute increased due to the shock level increasing. So what does this all mean? For one, shock rate may contribute to the strength of an avoidance response. Secondly, if you want to evoke an avoidance response, you should consider the strength of the conditioned stimulus you are presenting. So what do you think? When would you want to use negative reinforcement in a non-experimental way? I was thinking if you want to teach someone to come back from breaks on time, you might want to use a louder alarm sound and terminate the sound upon their return. I think it would be interesting if future research used different methods other than shock to test this theory with non-human animals. Thank you for watching. Here's a reference to my article. I highly recommend reading it. It was a good one.